Welcome back. Hope you're doing well. In continuation about my Matplotlib series of tutorials, today I'm going to be talking to you about bar charts. Before we go ahead, if you like my videos, it would really help and I would really appreciate if you hit the like button, subscribe to my channel, and leave a comment if you want to see more videos. Hello everybody, how's it going? Welcome back to my channel. As you remember, I have started a series of tutorials on Matplotlib where I'm taking you from zero to hero using Matplotlib. So there are two videos that I've already posted about Matplotlib. One of them is just general introduction, how to make your white canvas, blank canvas, and the second one was about making subplots. So if you haven't seen them, go ahead and click on the links respectively on the top right. All right, let's make a new Jupyter node. I'm just gonna give it a name, matplotlib_3, and this one is about bar charts. Today I'm gonna be talking to you about how to make very simple bar charts, read a CSV file. Before anything, just let's make sure I have Matplotlib installed. So if I run this command, which is import matplotlib, and I don't get any error, that means that Matplotlib is installed on my machine. And if I were to understand which version of Matplotlib is installed, I can just run matplotlib _version . You can use this for any other package. If you want to check the pandas version, if you want to check your numpy version, you can just put the name of the package and then .._version . From matplotlib import pyplot as plt, so we give it a nickname. To start an instance of a figure, we call plt.figure. Well, you're not going to really see anything because I'm not plotting anything, but at the same time, there is an instance of figure being created. If I say plt plot nothing for me, it will essentially give me a default blank canvas. I haven't given it any data, so I can't expect anything. The next thing is the size of the figure. So I want a 10 by 10 figure size here. That's a bit too big because it doesn't really help me to see everything beneath my figure. So I'm just going to make it 7 by 7. So look at the different styles that are available in terms of aesthetics. How do we want our figure to look like? And that will show you which styles are available for you to use. And if you want to use a specific one, and I'm going to use 538. So copy that one here. Okay. And if I run it again, you will see that even the blank colors and the shape does change. Forget about all of this. I don't really care about, styles for now. I'll just reset my notebook, run this again, and we are still looking at a blank canvas. We're gonna bring in some data, which I already have in my GitHub repository. So if you haven't seen my GitHub repository, I'll leave the link down below. Let's go ahead and copy the data from the other notebook, which is matplotlib_1. Just go ahead and copy this data and bring it into our current notebook. I have copied the data in here. And I have given _x to the age variable, _y to every other variable because I want the age to be on the x-axis. All right, let's start really simple. I'm just going to go ahead and delete Java and all salaries because I want to keep it really simple. I just want to look at people's ages and how much they make money if they are a Python developer. And this is the line plot that we got out of this. Remember that to add a legend, we said we can use the label keyword and say Python developers. And if I just run this, I'm not going to really see that in the legend unless I say plt.legend. And you will see Python developers popping up here. If I were to change this in its simplest format into a bar chart, I'm just going to say plt.bar, and that's it. I'm not going to change the x-axis, I'm not going to change the y-axis, and I'm not going to change the label. Look at this. I have a bar chart out of this data. Very simple. Is this a very ideal bar chart? Probably not, but does that convey the information? Of course it does. I wouldn't like this chart without a title. I wouldn't like it without any x-axis label and y-axis label. So the title is of Python developers and their plt.x label. So x label is age and plt.y label salary USD. Beautiful. The chart looks a bit more representative of what I'm trying to do. Let's see what does a bar chart really show here. So let me go back to the plot function, not the bar. In a plot function, we had age on the x-axis and salary on the y-axis. You can see that people around the age of 18 have a bit higher salary compared to 19, and then probably the same as 20, and the salary keeps going up as the age goes up. So there is this anomaly that people who are 18 are earning more money than the people who are earning 18 and 19. Is this a general rule? Not really. These are the results of a survey that was done. But if I convert this to a bar again, you can see that, well, yes, that is true. People who are 18 years old are getting paid a bit more than people who are 19, both of them on top of each other. So what if I said, keep the bar here, and before that, do the plot. So make a line plot and a bar plot. You can see that that line plot is sitting right on top of those bar plots. So let me just give it a color red so that you can see it. And that's essentially what you're plotting with these bar plots. Are you always using bar plots to show this? Not really, because normally bar charts show the frequency counts of values for the different levels of a categorical or nominal variable. So that's a mouthful, that's a lot of words, but essentially you can show frequencies of values. Imagine in a class of mathematics, you have 50 students. Some of them scored A, some of them scored A+, some of them scored B and C and D. Essentially, you can say how many people of all the students scored A+. So you give them a bucket. How many people of all the students scored A? You give them another bucket. And that's how you show the sizes of those bars and those buckets relative to those students in that class. Hopefully that makes sense. I'll show you more data on that one, but for now, this is a really quick summary. I'm just gonna do a bit of cleanup here. This is the main thing we're working on. If I go back and bring Java and all salaries, because I want to have plots of different languages and all the people who responded to the survey. Let me run that. Was for Python, and I'm gonna make one for Java. Copy this line, simply paste it down here. The age is the same, so ages are the same, and I'm just gonna say Java salary underscore y, just to show you that this is a y value. Let me do that for this one as well. Run it again. Put Java salary y instead of Python salary y, because I'm doing Java now. Let me plot this and see what happens. I need to change this to Java so that I know. Java developers in orange are kind of sitting on top of Python developers. Well, I can see Python developers in blue behind the orange because they were higher values. Had I done them in a different order, so if I had plotted Java salaries first, let's do this and paste it before Python, and I am not gonna see Java salaries because now Java is in blue, which is sitting behind the orange ones, which are Python developers. So what I'm trying to tell you is that what I'm doing here is not really smart. I don't want them to plot on top of each other. However, I want them to plot right next to each other. In order for us to plot these side by side, we need to do a hack. We need to move the blue ones to the left, and we need to move the orange ones to the right to see them side by side. Let's start with a parameter of width. I believe the default number is 0.8, so I'm just gonna put the default number. What this parameter controls is how fat, how wide the bars are. So let's make it, you can see that it's very close to what it was before. If I make this 0.2 only for Python, you can see that Python is very, very narrow. And if I do that for Java too, you can see that they are very narrow. I know how to control how thick these bars are. The next thing will be for me to shift one group to the left and shift the other group to the right, or just keep one of them and shift one group very further to the right or very further to the left. What I'm gonna do now, I'm just gonna make a variable for width, and I'm gonna say, let's set it to 25. And instead of putting these as number, I'm just gonna set it to my variable width so that I can control them centrally. That is easy right now. All right, let's talk about the hack. Let's talk about how to move these to the left and right. Before anything, go ahead and import NumPy library as NP. I don't think we have talked about NumPy so far. When you have your Python installed in your machine, NumPy normally comes by default. So I'm just gonna run that, and I'm just gonna make a new cell here, and I'll tell you what I'm doing while I'm doing it. I'm just gonna call the function called aRange, which produces a range of numbers. And what range am I making? I want age underscore x, and I want to get the indices. I don't want to get 18, 19, 20. I want to get 0, 1, 2, 3, and so forth. So if I run this, you'll see I have 38 numbers in the age axis because it starts from 0 all the way to 37. I'm gonna call that x indexes, Okay, that goes into a variable. Why am I doing this? Because that allows me to manipulate these bars easily. Instead of plotting underscore x, I'm just gonna say plot indexes, x indexes for both plots. And now I can easily manipulate them by saying, I want you to move Python width amount to the left. That's why I'm doing subtraction from x indexes. Move this one width amount to the right. So what I'm expecting to see when I run this, I'm expecting to see the blue ones coming to the left and orange ones going to the right. Let's run that. Look at this. This is really cool. I can now see that blue and orange are sitting side by side, but there is this little gap that makes this plot really confusing. I don't know which is which. So what if I went ahead and only moved Python and didn't move Java at all? What happens then? This is much better because I know that this blue corresponds to this orange about the people who are of age 18 years old. The next one is for people who are 19 years old. Let me just add to the width of this graph. Okay, this looks a bit nicer. And let's add this to 0.5. Okay, maybe just a bit too much. Add 0.4. This looks much, much, much better. I can actually compare blue to orange one by one. Now that we have done this, can we also plot the all salary right next to these ones? We are just gonna make another set of lines, copy this. I'm just gonna copy and paste because I'm lazy. And I'm just gonna say all developers. I'm gonna keep x indexes. I'm gonna come back to that. My y-axis will be all salary underscore y. That's what I want. I'll call this all developers. Easy. Capital D for housekeeping. If I run this, I think you would imagine that it will plot on top of orange because there is no movement. There is no movement as such. All I need to do, I'll say plus width. That's cool. Well, not really, because some of them are plotting on top. Maybe I should reduce the width to 0.25 again. Okay, this is much better because I can compare Python developers in blue, Java developers in orange, and all developers in green all the way. And we can see that Python developers are better paid most of the time. The plot is very much done, but I don't want to see the age going from 0 all the way to 35, 6-ish, because that's not the age. The age ranges from 18 all the way to 55. So we need to do something. Let's go and use xticks. Xticks function cares about these ticks, these tick values on the x-axis. What we need to do right now, we will say, all right, ticks equals x indexes. So that's the ticks that we have, but the labels for them will be age underscore x. Look at this. It runs from 18 all the way to 55, which represents the data. Let's bring this down and add it to this. Maybe let's just add a grid. Cool. The grid is a bit too much. I'm gonna add a transparency of 0.6 to make it a bit more transparent. Okay, that's suffer now. Sometimes you need to plot bar plots in a horizontal direction. So you want them to go from left to right rather than from bottom to top. There are different reasons why you would like to do that, but I'm going to show you how to do that. Before we go ahead, let me show you this data.csv. It's in my GitHub repository. Feel free to go ahead and download it and do your own experiment. If I open this CSV file, you can see that I have different programming languages, HTML, Java, JavaScript, Python, C++, all the way. And the number of their appearance in the survey on the Stack Overflow website. So for example, HTML/CSS appeared 55,466 times in that survey. We want to make a bar chart that shows the frequency of their appearance in the survey. To do this, let's go ahead and open just a fresh notebook. I'm just going to click on that plus sign, open another Python 3. Just going to say from Matplotlib, import pyplot as plt, import numpy as np. And I'm going to use pandas library to read the CSV file. So import pandas as pd. And I'm just going to rename this file to matplotlib_3_ horizontal bar. Let's read the data, pd read underscore CSV. If you haven't seen my pandas tutorial, feel free to click on the top right and you will see a very quick and nicely put together pandas tutorial. Just the name of the file, so that's data.csv. So this is the head of the data, the first 5 rows of the data, language, and the frequencies. For example, for HTML, we have 55,466. So plt figure, I want a fig size equal to 8 by 8. As we said before, this is just to show you that we can start plotting things using plt plot. We're not going to be using plot function. We're going to be using bar function. All right, if I do this, I'll have the empty canvas. Let's change this to bar because I'm going to make bar plots. On the x-axis, I want to put the languages. So the languages will be in the column language. And on the y-axis, which comes next, I'll use frequency. Spell that right. Brilliant. Well, I don't really like the x-axis because they're printing on top of each other. And that's the reason I would like to use horizontal bar charts. So if I go bar H, look at this. This is a much better representation of data. For example, I know that for HTML, there are more than 55,000 people who answered in the survey. And for Dart, there's like 3,000, 4,000. Probably I should add PLT grid because that makes it easy to read numbers. Yeah, this is easier. Just gonna make it a bit more transparent. All right, that's not as bad now. Let's add a PLT title. What do we call it? We say number of corresponding language. Okay, so that's the title. PLT X label. Okay, oops, sorry, that's the Y label. And the X label is PLT X label. Just call it frequency. Cool. So frequency down here, programming language there. What I would really like to do is sort these values by the number of their appearance, because you can see Dart is lower, Scala is going really higher and then coming back up. I would like them to be like in a really nice increasing, ascending or descending shape. How can I do that? Well, that should be pretty easy. What I will do, I'll say data equals data.sort values and sort it by frequency. Let's do that. You can see that now JavaScript is sitting on the top, HTML just below that, and this looks really nice going from higher number of appearance to the lowest number of appearance. The last thing I want to talk to you about is to use our knowledge from my previous tutorial on Matplotlib subplots. I'm just going to do a very simple subplotting here just for the purposes of this tutorial. I'm just going to do one subplot as you can see in the photo. So I'm just going to put it in one of the figures. And for the next figure, I'm going to plot the same thing, but in the reverse order. So Erlang should be up there, and then F#, and then WebAssembly, all the way going to JavaScript. If you have not seen my video about Matplotlib subplots, go ahead and click on the top right link, and you will see the tutorial for subplots. Now, for now, fig axes equals plt subplots. I want one row and 2 figures, fig size of 14 and 7, plt plot, plt.show. All right, I have 2 subplots that are living inside the axes variable. If I print the axes variable, you will see there is one axes subplot and there is another one. This is index 0 and this is index 1. Okay, for index 0, I'm gonna make a horizontal bar chart. I'll copy this here, okay, and paste it here. Well, you will see that I have exactly the same plot in plot on the left. It is very simple. It doesn't have any grid. It doesn't have any legend, and I will do them later. But for now, I just want to show you how I can do this in different subplots. So that was axis number 0. I'm just going to copy that, paste the same thing. However, put it axis number 1, which is this plot, and let me just change the color so that you can see which one is which. Beautiful. So I have 2 subplots right next to each other. They're exactly the same. So you can see that this text is printing in the middle of the other plot. So if you remember, we can use subplots underscore adjust and give it a W space of probably 0.4. It allows some nice spacing between the two graphs so that they don't print on top of each other. Now, what I want to do, I want to change the order of this one from higher to the lower into lower to the higher. So let's go ahead. I will need to sort values again. Sort the values like this. And when I come for the second one, I'll say ascending equals false. You know, this is exactly the same data. Nothing has changed. I just wanted to show you how to put two different bar plots into subplots. Good luck with everything, and thank you. Please go ahead and subscribe to my channel. Hit the bell to get notified when I post new videos, and that really helps me to grow my channel as well. Thank you.